Hey guys, another little video just to help you out with the second con skill, solving sinusoidal equations. And it says basic there, but this is tough stuff, guys. So if you're struggling with it, that's okay. That's why you only get 4 problems of it this week. Okay, so I think I actually did this one in class today, and I'm going to help you guys out with it. So it says solve the equation on the interval of negative pi over 2 to 5 pi over 2. And this right here is what is the trickiest. So we're going to come back to this in just a second. This is what makes it so tough. But I do want to just make sure you know your answer for this one should be in radians, because this is going to jump back and forth between radians and degrees. So it's saying my cosine is negative 0.7. So if I want to solve for x, because that is the goal here, I need to do the inverse cosine of negative 0.07. So I'm going to put that into my calculator right now and figure out what that is, making sure my calculator is in radians. So I'm actually going to use, let's see if I already have it pulled up. Maybe I don't. Look at all this junk I've got here, guys. Here it is. I'm going to use Desmos Scientific Calculator because it's really easy to switch back and forth between degrees and radians. So the inverse cosine of negative 0.7, and I wanted it in radians, so I'm just going to switch it over radians. So there we go. My angle is 2.35. So 2.35, and that feels weird because it's not pi, but that's okay, because if I think about where that fits in on my unit circle, this right here is 0. The top is pi over 2, which as a decimal is 1.57. Half of the circle is pi, which is 3.14. So yeah, 2.35 is somewhere in this quadrant, and that makes sense because that is a negative cosine value or a negative x value. So let's find its matching cosine value, which would be down here. Let's find his matching cosine value. Hold on one sec, guys. Okay, so if this right here is 2.35, I need to know what this reference angle is right here, or what's the difference between 2.35 and pi. So this angle is actually just pi minus what I got in my calculator, 2.35. I am going to figure out what that value is. Pi minus my answer. It's 0.795. I'm going to keep all those decimal places just so I don't over round. So that angle there is 0.795. And that's important because pi minus 0.795 gets us to the 2.35, and pi plus 0.795 will get us down to that other angle which has the negative 0.7 cosine. So my second angle that I'm looking for down here is pi plus 0.795. Pi plus that answer, or 3.94. Now I'm okay rounding it off because that is one of the answers. So this one right here is 3.94. So we have kind of two answers to start with, 3.94 and 2.35. Now let's kind of go back to that domain and let's find the angles within that domain. So I'm going to draw the circle again and just kind of mark off what that domain actually is. That domain starts down here at negative pi over 2. Negative pi over 2. It comes up here to 0. Then it makes a full circle from 0 back to 2 pi. And then extends another pi over 2 to 5 pi over 2. So essentially, we're getting a full circle and an extra half. So we're looking for every time we cross over this angle, which in the first rotation is 2.35, and this angle, which only in the first rotation is 3.94. Okay, so let's kind of make our way around the circle. I'm just going to kind of demo that. Starting here, I haven't hit that point yet, so I'm going to keep rotating. Now I'm starting at 0. I haven't hit that point. I haven't hit that point. Bam. There in our new domain, that is the first time we cross that point. So 2.35, that is one of the ones we want to keep. Okay, I'm going to keep going. I'm going to keep going. Yep, I hit that point again. So that is one of the ones we want to keep. And then I'm going to keep rotating. I still haven't hit another point, and rotate that last little quarter of a circle. Stop. So I really only hit those two cosine values twice, once at 2.35 and once at 3.94. So that should be my answer. Let's check. Okay, let's try one more problem. Here, this one is asking us to find one or more expression that represents all solutions in radians. So all solutions is a little bit different. Last time when you were given a domain and we had to find all the angles within the domain, this one, instead, we're just going to find the first solution or maybe one solution and then say, well, how often does that solution repeat? So let's start by finding that one solution first. X is going to equal the inverse cosine of 0.35, and we are in radians still. So let's find that principal solution, by the way. That's what it's called. The one your calculator gives you, or that very first value, is called the principal solution. Let's find it. Let's clear all this. We want to do the inverse cosine of 0.35. Whoops. 35. And in radians, our principal solution is 1.21. 1.21. Cool. So just to give you guys a visual for what this actually means, this is 0 here. This is pi over 2, which we can also write as 1.57. 1.21 is somewhere in there, and that makes sense because, yeah, that's a positive cosine value. That's a positive x value. Oops, didn't mean to hit that. Sorry, guys. So if we have that solution, where else in our unit circle are we going to have that same x value? Well, directly below it at that angle, we'll have the same x value. So if this angle of rotation is 1.21 radians, this angle is also 1.21 radians. So that would just be 1.21 radians short of the full circle, or 1.21 radians short of 2 pi. So what is this bottom angle? 2 pi minus 1.21. It's 5.07. So that bottom angle there is, I'm going to put that in color so you can see it, 5.07 radians, and this top one is 1.21 radians. So those are the first solutions, meaning the first rotation of the wheel. So as we rotate around the wheel the very first time, bam, we hit this point, keep going, keep going, keep going, keep going. We hit this point. Okay, that's one rotation. Everything we do after that is just repeating what we did before. And I just ask, how often does it repeat? Well, how often does each one repeat is just, well, how long does it take to get back to this point? How many degrees from this point right back to where we started? How many degrees or radians from this point to right back where we started? And since it is just a full circle, that number of radians is 2 pi. So we would want to say this first angle, 1.21 radians, plus every rotation of 2 pi. And our second angle, 5.07, plus every rotation of 2 pi. Which, let's see if that one's there, because there are different ways to write that one. So it looks like that one isn't there, but let's think about it a different way. We know that this is also just 1.21 in the negative direction. So we could instead write this as negative 1.21 plus every rotation of 2 pi. And that one actually shows up. So we're going to choose this guy right here, negative 1.21 plus every rotation of 2 pi, and this guy right here, positive 1.21 plus every rotation of 2 pi. Okay, hopefully that helped. Please bring any questions you've got